Have you ever stood in a quiet forest, looked up, and felt very small? Surrounded by ancient trunks and the hush of leaves, it's easy to feel a sense of awe, as if you're standing in the presence of giants. You tilt your head back until you see the top of a giant tree touching the sky, its branches stretching far above, almost out of sight. It makes you wonder, how does a tiny, fragile seed become a towering giant that lives for centuries, weathering storms and changing seasons? This is a story of strength, cleverness, and a patient journey toward the light. Every tree is on a quest, reaching ever upward, competing for sunlight in a crowded world. Trees are more than wood. They're living beings solving big problems, adapting to their environment, and finding ingenious ways to survive. How do they grow so tall without falling? What keeps them anchored and stable even as they sway in the wind? How do they get water to their highest leaves, sometimes hundreds of feet above the ground where the air is thin and dry? Imagine drinking through a straw as tall as a skyscraper. An impossible task for us, but a daily reality for these natural wonders. That's what the tallest trees do every day, lifting water to dizzying heights, defying gravity with silent determination. They pull water from deep in the earth, lifting it hundreds of feet, silently without machines, using only the power of nature and their own remarkable design. This quiet miracle happens in every forest, every day, hidden in plain sight as we walk beneath their branches. Let's explore how trees achieve this feat and uncover the secrets behind their incredible height and resilience. We'll look beneath the soil, up into the canopy, and inside the bark to reveal the hidden systems that keep trees alive. We'll discover how trees support each other and communicate, forming networks that help the whole forest thrive. The story of a tree's height is about more than wood and leaves. It's about community, patience, and the wisdom of nature. By the end, you'll see trees in your park or backyard in a whole new way, understanding their struggles and triumphs. You'll recognize them as the true kings and queens of the forest. Let's begin our journey into their world. A tree's life starts with a single, fragile sprout pushing through the soil, reaching for sunlight and hope. But from the very beginning, it is driven by a deep thirst for water, the most essential ingredient for growth. Underground, a vast and intricate network of roots stretches out in all directions, searching tirelessly for moisture and minerals hidden in the earth. Tiny root hairs, almost invisible to the eye, absorb precious droplets of water, beginning a remarkable journey upward through the tree. Roots create gentle pressure, giving water a boost into the main root system, especially at night, when the air is cooler and moisture lingers in the soil. A tree's roots can spread 2 or 3 times wider than its branches, forming a huge hidden network just below the surface, anchoring the tree and exploring for resources. Roots hold the soil together, preventing erosion and landslides, while the soil in return provides water and vital nutrients for the tree's survival. Underground, roots of different trees often connect, linked by friendly fungi, a vast living network sometimes called the wood wide web. Through this network, trees share water and nutrients, sending help to neighbors in need and increasing their chances of survival. A large, established tree can even send water to smaller, struggling neighbors, nurturing the next generation of the forest. This cooperation strengthens the whole forest, making it more resilient to drought, disease, and storms. When a tree drinks, it often shares with its neighbors, creating a community where survival is a shared effort. The root system is both a lifeline and a community, connecting trees in ways we are only beginning to understand. Trees thrive not just by competing for resources, but by working together, supporting one another through their underground connections. The journey of water begins with teamwork below the surface, where every root and every drop matters. It's a beautiful example of nature's interconnectedness, reminding us that in the forest, survival is a shared story. Once water enters the roots, it travels up through the tree's plumbing, the xylem. Xylem tubes, like millions of tiny straws, run from root to leaf. The sun drives transpiration, water evaporates from leaf pores, pulling more water upward. Water molecules stick together, forming a chain that climbs the xylem. This silent engine lifts water over 300 feet in the tallest trees. No energy required, just physics. On a hot day, a large tree can pull up over 100 gallons of water. Next to the xylem is the phloem, which carries sugary sap from the leaves to the rest of the tree. The tree's two-way highway, water and minerals go up, food goes down. This system keeps every part of the tree alive and growing. It's a marvel of natural engineering. Every drop of water and bit of sugar is carefully delivered. The tree's survival depends on this perfect balance. A tall tree needs a strong foundation, its roots. Roots anchor the tree, gripping soil and rocks to withstand wind and snow. Some trees have a deep taproot for stability and water access. Others have wide, fibrous roots for surface grip. The combination of deep and wide roots gives trees both strength and flexibility. In forests, roots of neighboring trees often intertwine, creating a vast interconnected web. When wind pushes one tree, its roots pull on others, making the whole forest stronger. Trees in a forest are safer than those standing alone. Roots also prevent soil erosion and help the ecosystem thrive. The strength above ground depends on the network below. Trees are not just individuals, they're part of a community. Their roots are both anchors and connectors. This underground teamwork is key to their survival. The forest floor is a single living web. Together, trees stand tall against nature's forces. The trunk is the tree's body, connecting roots to leaves. It stands as the central pillar, holding the entire tree together and giving it shape. Without the trunk, the tree would have no way to reach upward or spread its branches wide. It's a masterpiece of engineering, strong yet flexible. The trunk must support the weight of countless branches and leaves, all while withstanding the forces of nature. Wood is made of tough cellulose fibers glued with lignin, making it both sturdy and resilient. This unique combination allows the trunk to resist snapping, even in powerful storms. Each year, the trunk adds a new ring, telling the story of the tree's life, good years and bad. These rings are like a living diary, recording droughts, floods, and seasons of growth. At the center is heartwood, a dense core that provides strength. This heartwood is often darker and more resistant to decay, acting as the tree's inner armor. The trunk must bend with the wind, not break, so it's both rigid and flexible. This balance lets trees survive storms that would topple less adaptable structures. Sapwood, the outer layer, is younger and more pliable, while heartwood is solid and strong. Sapwood also carries water and nutrients up from the roots, keeping the tree alive. Bark protects the trunk from insects, disease, and weather. It's the tree's first line of defense, shielding the living tissues beneath. Some trees have thick bark that even shields them from fire. This adaptation helps forests recover after wildfires and ensures the survival of ancient giants. The trunk is more than a pillar. It's a living structure for support, transport, and protection. It moves water, minerals, and sugars throughout the tree, keeping every part nourished. It lifts the leaves to the sun and anchors the tree's story in every ring. The trunk is the bridge between earth and sky, connecting the roots below to the canopy above. The trunk's design allows trees to reach incredible heights. Some species soar hundreds of feet, all thanks to the strength and structure of their trunks. It's a blend of strength, flexibility, and defense. Every trunk is a marvel of natural engineering, perfectly adapted to its environment. Without the trunk's engineering, trees could never touch the sky. The forest would be a very different place without these living columns. It's the backbone of the forest giants, supporting life for centuries and shaping the world around it. Some trees are true champions of height. The coast redwood is the tallest, growing along the California and Oregon coasts. The tallest living tree, Hyperion, stands at 380 feet, taller than the Statue of Liberty. The giant sequoia is the largest by volume, with massive trunks like ancient pillars. General Sherman, the largest, is over 2,000 years old. In Australia, the mountain ash is the tallest flowering plant, racing skyward in wet forests. Douglas firs in North America and yellow moranti in Borneo also reach impressive heights. Each giant tree is a testament to nature's power and perfect conditions. They thrive where water, sunlight, and shelter align. These giants are living monuments to endurance and adaptation. Around the world, tall trees push the limits of what life can achieve. They inspire awe and remind us of nature's possibilities. Standing beneath them is a humbling experience. Why do trees grow so tall? It's a race for sunlight. Sunlight powers photosynthesis, turning water and carbon dioxide into sugar, the tree's fuel. In dense forests, light is scarce on the ground. Growing tall lets trees capture more sunlight, outcompeting neighbors. Height also helps with reproduction. Seeds and pollen travel farther from high branches. This spreads the tree's legacy and increases genetic diversity. But there's a limit. Pulling water to the top gets harder as trees grow taller. Around 400 feet, physics sets the ultimate height limit. The tallest trees balance ambition with nature's constraints. The race for the sun shapes forests and drives evolution. Height is both a strategy and a challenge. Trees push upward but must obey the laws of nature. Their struggle for light defines the forest's story. Growing tall is one thing. Staying tall for centuries is another. Tall trees face storms, wind, and weather. Their trunks sway with the wind, absorbing energy instead of snapping. Many have cone-shaped crowns wide at the base and narrow at the top to shed wind and snow. Branches angle upward, reducing drag. Some trees adjust their leaves to let wind pass through. Others, like deciduous trees, drop leaves in winter for less resistance. Even with defenses, damage happens. Branches break, trunks are wounded. Trees heal by sealing wounds with resin or sap, protecting against disease and insects. New wood grows over scars, allowing the tree to endure. Every scar tells a story of survival. Their resilience is built into their design. Endurance is as important as height. Trees are masters of both. Tall trees are vital for our planet's health. They act as Earth's lungs, absorbing carbon dioxide and releasing oxygen. A single large tree can provide enough oxygen for a family of 4 each day. Forests of giants help stabilize our climate and fight climate change. These trees are the heart of ecosystems, providing homes for countless creatures: birds, mammals, insects, and plants. Their shade creates cool, moist environments for life below. Each ancient tree is a bustling city of life. For humans, forests offer peace, inspiration, and clean water. Roots filter rainwater, trunks give us wood, and canopies provide shade. They are gifts that ask only for respect and protection. Protecting ancient forests preserves homes for millions of species. Once lost, these giants can't be replaced in our lifetimes. By caring for forests, we protect our climate and future. We ensure that generations to come can stand in awe beneath these living wonders. Tall trees are treasures. Let's keep them standing tall.